Start the recording. Okay. Okay, oh no. Let me share to the screen, please. Okay, so I'll share the video of this whole transcript with you, and also any code that I'm writing, I'll have that on the website also, so you can take a look at that and work with that for your homework. Any questions before I get started? Let's just start with some basics. I'm gonna make this a little bigger. All right. Something that's always useful, especially when you're first starting out, is just get something running. So whatever it is, get your Hello World running first before you start adding code to it. So if you remember, once you have this Hello World, you want to do two things. So you're going to be compiling it with the Java C, paying attention to any errors that happen. If there are no errors, then you'll see that you have a .class file, and you can run that .class file by using the Java program with the name of the class. So when you give it the name of the class, then it looks for the class file with the same name, and then it looks for the main function inside that class file, and then it starts running the main function. Right. So let's. I just wanted to show you some things that you know about from processing, but to remind you about some of these things. First of all, we can declare variables. We can declare local variables. For example, here I'm going to declare a local variable n. And we can then print it. And so here, I'm going to compile and run this, so you can see what's happening over here when we run that. So you can see we're printing that value 5. The way I like to think about variables is you have a box. The variable has a type. It's our integer. There's our name of the variable. And there's a value in there. Right, our value goes in the box. There's a variable, so the value can change. Right? But in Java, the type cannot change, and the name cannot change. So, for example, I can say n equals 7 here, and then I can print out the value again, and I'll show you what that looks like. So you can see what I'm doing here with the code is that I'm changing the variable to 7, that's putting the 7 in the box, and then I'm printing out the current value. Right, so okay, so these variables work the way you'd expect them to. You've seen this in processing, right? So this is what's one of the standard types, and there are other standard types. There's one called float. Float stands for floating point, which is how you do decimals. And actually, the same thing happens. So you can let's just print that out so you can see it. Okay, this is going to be an error that you're going to see. What does this even mean? Incompatible types, possible lossy conversion from double to float. Okay, so there are actually two types of floating point types in Java. you've only seen one of them. In processing, everything was a float. But there's also what's called double precision. To avoid this error, when I'm going to put, after this 1.23, I'm just going to add an F over here. And that means use single precision. And it'll do what I expect. If the other way I can get around this is I can use a double. So what does double mean? It means it's higher precision. It's double precision. So it goes out more decimal places. Like a normal floating point, it usually goes, you can count on it for about 5 or 6 decimal places. Double precision, more like 13, 14, something like that. So a lot higher precision. Yeah, Claire.
Why do you need the F after the
Okay, yeah, so again, oops. Why do we need that F? Okay, so what's happening is without the F, when you give it a literal like this, a number literal, Java interprets it as a double precision floating point number. And, but I'm storing it in a single precision variable here. So the F, what I'm telling it is I really want a single precision. And if I don't, then it's going to give me an error because what you don't want is for something that you don't expect to happen. So if I give it all this precision and then I store it in something that can't handle that precision, then that's going to truncate that number and things are going to be unexpected. So this is just to avoid that error. You can use doubles for everything, and you won't ever get this error. So, Luna.
This is pretty general, but is there a difference between an underscore and a space?
Yes. So an underscore is actually a character, which you can use as in the variable. So I could write, for example, my number. Yeah, you're right. Okay, hold on. Hopefully I will in a second. No. I don't know if what I should do is probably, let's try that again.
But also, I'm confused by a space because sometimes things don't work when there isn't a space, so it kind of acts as a character. Right? Or at least
Not
in terminal.
Okay, oh, so you're talking about terminal, which is different. Okay, so terminal is going to be different from Java.
Okay.
In terminal, the space, so everything is tokenized by spaces. And so what that means is you give it a command, and then you give it a space, and then you give it something else, and you give it a space, and everything is separated by spaces. Java is actually a little bit different. So 1 second. Okay, good. So we can see this. So first of all, what I was showing you here is that I can use this underscore over here, and that becomes part of this variable name. Right, so I can use my number here is the full variable name, and I can print that out using my number here like this. You cannot use a space in a variable name. Okay, so yeah, so that's white space is what separates everything, actually, both in Java and in terminal. Usually we will not use this style of variables though. So this style of variables, variable naming for number is more often used in the C language. More often what we'll see is something like this, which is what you've used in processing. So this is called camel case. So this is lowercase, right? This is lowercase. Here's capitalized. And this is called camel case because you start with a lowercase, but then every word after that is a capital. It looks like a camel, right? Okay. So that's generally used for Java and processing, is camel case. You'll see this, sometimes this is called I think snake case. You'll use it more for C and sometimes for Python. Depends on who the coder is. So in Java, generally the convention is to use camel case. But if you do decide to use some other convention, like snake case, be consistent. Otherwise, you're going to confuse people. But the one main thing is your variables should all start with a lowercase letter. And your classes are going to start with an uppercase letter. So over here, if you look at the class, this is capitalized. All the variables are going to be lowercase starting. So either lowercase or snake case or camel case. Oh yeah, these are comments, right? These double slashes. So the compiler just completely ignores anything after the double slash. These are great for giving yourself hints about what your code is doing, right? If you want a multi-line comment, everything between the slash star and star slash is a comment. Okay, so again, the compiler just completely ignores all that stuff. Okay, so what do we have? We have integers, we have floating point, we have double. Okay, so you're going to be very familiar with those three data types. There's another basic data type called a Boolean. What is a Boolean? Boolean means true or false. Those are the only two values you can have, true or false for a Boolean. Okay, so that's useful. A lot of your, we'll be seeing that for, actually you've probably seen that for in processing before for turning things on or off, possibly. What you can't do is, for example, assign a number to a Boolean variable. Right, and that's for the same error that happened when we tried to assign a double to a float. Okay, so you can't mix the data types. There's one exception though. With numbers, there's going to be a promotion. So if you try to assign an integer to a floating point number, that's going to be okay, right? Because you have more expressive power. And if you try to do a float to a double, then that's going to be okay also. I'll let you read about that, and you'll see as we work with it. Okay. So I'll just leave that error in there. So again, you'll have access to I'll put this on the website as soon as we're done. Any questions about the basic types? Those are the four basic types you'll be using all over the place. So int, float, double, and Boolean. There are other types though, and these are going to be reference types. So these are actually. Let me just write this out here. Let's call this. I'll write this basic types. Sorry, like int, float, double, Boolean. And now we'll talk about reference types. Which will be string and lots of other things. So string is one that you've seen before. So we can have a string like so we can write a string, any set of characters that's between these double quotes. And then we can print it out. And we can even assign it another string, right? So there's So when we're there's something different though about this string. It's called a reference type because we can't fit this whole string in a box like that, right? So the basic types, we have a box. We can put a single number in there. We can put a floating point number in there. We can't put a whole string in there. So string is actually a class. And when I'm saying that hello here is an object of this class, we're going to learn a lot more about classes and objects. But just so you see that you've already been using these objects as strings. But what's different about the reference type? And we'll talk more about this too. Is that when we have a string, call it S here, there's really some number in here that's going to refer to the actual memory location of the string. Because we can't fit the whole string in that box. So the way we have to do it is have a number that represents a memory location, it's called a reference, that points to where the actual string is. That's enough for now. We'll be talking lots more about those things. But the main thing is that with a reference, it's not the actual value in the box. It's referring to the value that's outside the box. And again, we'll be talking about classes and objects in like 3 or 4 weeks, something like that. Okay, here let's do. Here, let me start a new file. And we started talking about loops last time, but let's talk about them again. Okay. So let me write out this for loop that we were looking at last time. And I'll remind you, this is our initialization. Okay, so we have 3 parts to this for loop: our initialization, our condition, which is I less than 10, and our update, which is I++. So we're adding 1 after each one of these things. Okay, so let's just start off with this, where we're printing out the numbers from 0 to 9. Remember, when you count in computer science, we're always going to start from 0. Okay, so I was showing you right at the end of last time how we did a condition, and it was just to remind you. So, for example, if we were checking to see, do you all remember, how do we check to see if I was even? Look at the remainder. Yeah, how do we do the remainder?
Divide by 2 and you use a percentage.
The percentage sign, which is the modulus operator. Yeah, so if our remainder when we divide by 2 is 0, what does that mean? That means it's even, right? Otherwise, let's print out the number, right? Okay. One thing you might notice, when I do the print line function, I can give it a string or a number, and it knows what to do. So it actually can switch based on the type, and it can handle any kind of type in this print line. Okay, we're looking at, let's say we wanted to do something else. Let's say we're first going to check to see if it's even. Otherwise, let's say that with the number 7, that we know it's a lucky number, right? So I can put another condition in here. I can check to say, if I is 7, let's do something else. So what is this code? Oops. Oh, what happened? Over here, this is my first thing. I'm checking this first condition. If it's even, then I print out even. Otherwise, so else, I check to see if it's 7. I'll print something else. Maybe I'll print lucky. Right? And if that's not the case, this is my default case, right? The else is just no matter what happens, there's going to be this else. So let's just take a look to see what that does. Right? Good? Make sense? Okay. You might notice that I'm putting braces here everywhere. You actually don't need to if there's a single statement inside the braces for your condition. It's safer to do this because if you add a second statement, then you want to keep it in the braces. Okay, so one of the homework problems, one of the homework coding assignment problems is a game called FizzBuzz. Do you guys know FizzBuzz from elementary school? Did you not play FizzBuzz in elementary school? So you go around the room, you go 1, 2, 3, 4, 5, 6, 7, like that. But there's the rule, which if it's a multiple of 3, you can't say it, you have to say fizz. And if it's a multiple of 5, you can't say it, you have to say buzz. And if it's a multiple of both, you got to say FizzBuzz. So you go 1, 2, fizz, 4, buzz, fizz for 6, right? 7, 8, fizz, buzz, 11. Right? Make sense? Okay. You're going to write a program that does that, right? So it's going to look like this. You're going to go through, you want to go up at least to 30 or so, and I put that in the assignment. I'll show you the assignment. But you can see it's going to look a lot like this. You can imagine how that's going to look, right? Okay. Here, actually, let me add one thing that might be helpful to you. If I is 7, or let's say if I is equal to 3, let's say it's lucky. That double vertical bar is or. What's and? Double ampersand. So that's how you do the logical operators. You might have seen that in processing. Yeah.
If we set instead of I modulo 2, if we set that like if it's odd then print odd, then would 7 and 3 come out as odd and lucky or?
That is a great question. So let's say we did this. What's going to happen? Okay, why is it going to skip over it? Right, so this statement is already true, so any odd number is going to print lucky, so it will never get here. Let's take a look at that. Does that make sense?
Okay.
Because it checks the first condition first, and then if that's true, then it does it. Right. So great question. I'm going to move this back for the purposes of the okay. Good. Do you have an idea of how you could do FizzBuzz based on this? Any questions? Okay. I'm going to show you a couple other things. Let's talk about sequences. That's the rest of the homework is going to be generating some sequences. And what do I mean by what do I mean by sequences?
Posting and stuff.
Yeah, I'll be posting all these. So using a loop again. So for example, let's say I wanted to print the multiples of 7. I could do that in a few different ways, right? What's one way I could do that? Less than something. There's lots of different ways. So what's the first thing that comes to your mind? Okay, let's try that. We're going to loop through all the numbers. Let's say a bunch of numbers up to 100 maybe. And I say if I modulo 7 is equal to 0, so if I'm a multiple of 7, then I'll print it, right? That looks like it could work. Oops. 0, 7, 14. Looks good? Yeah. How else could we do it? Add 7 each time. Okay, here let's go less than 100. Let's just go up to like 50 first, and then I'll add 7 each time. Okay, what does that mean? I mean, so we have to keep a running total, right? Okay. Okay. So here's another way to do this. This is actually a good illustration. Okay, so let's say up to 50, but instead of going I plus equals 7, right? I plus equals 7. What does that I plus equals 7 mean? It means I is equal to I plus 7, right? We're adding 7 to it and going up. What does I plus plus mean? I plus equals 1, right? It's the same as that, right? Or I equals I plus 1, right? So all these are the same. So these are this is what's called an assignment operator. So there's lots of assignment operators. We know about the equal sign being an assignment. The double equals, that's not an assignment operator. What's that? That's our comparison, right? That's why when we're comparing stuff, we're using the double equals. So when we're assigning with the single equals, comparing stuff, we're always using the double equals. But then there's these extra, like plus equals. That's also an assignment operator, which is a way of adding to it. There's also times equals, divided by equals, etc. Okay, that's great. So this one's, is this enough? Looks pretty good. Yeah?
So all their assignments under like our class page is practice for the test.
Yes, so I'll tell you exactly what the quiz is going to look like. But the next quiz for Unit 1 is going to look very much like your code assignments. And that's going to be the case for every week. Yeah.
Do we have a quiz next week?
Yep.
Around
Whenever you're ready.
when?
So, ideally, you'd be ready by the first class of the week. But if you're not, I want you to tell me. And then we can postpone it to later in the week. Okay? Also, ideally, you'll do it then next week, right? So I'd rather you not push it back more than a week, because then you start getting behind. But I know there's circumstances, so just let me know where you are on everything. How else can we do this? This one's really short, right? It's almost hard to see what's going on there.
You can list every one manually.
Yeah, you could do that. Yeah, if you like doing math, then you could do that, right? You could do all the math on your own and print 7, 14, 21, 28. You could do that.
Could you divide 100? Could you divide a multiple of 7 by 7?
You do it like with a factorial.
I was thinking something actually a little simpler. Let me show you 2 ways, which for those of you who have taken some pre-calculus, you might know these. So when you have a sequence like this, where we're actually adding the same amount to this sequence every time, right? We're adding 7 each time. Anyone remember what that kind of sequence is called?
Arithmetic.
An arithmetic sequence. So with an arithmetic sequence, we have a couple ways of generating the arithmetic sequence. We can generate it with a formula, with an explicit formula, or we could do it recursively, which is kind of like what we were just doing here. So, but let's be explicit about these explicit formulas. What's the explicit formula that would generate this sequence? I'm sorry? That would be a recursive formula, right? So when you're adding, so that's giving the next thing in the sequence. What I want is, if I give you the position, what's the value going to be? So if I gave you position 5, what's the value going to be? If I gave you position 0, what's the value going to be? If I give you position 1, you see what I mean? So we have the sequence over here, 0, 7, 14, 21, and I have my numbers. So is there a formula that can give me here's my I. I want to have my function that's going to give me my actual sequence.
Or just I times 7.
Yeah, I times 7, right? That should work. So that's my formula, is I times 7 here. So I can just write that, I times 7, right? So I'm generating my numbers from 0 to 6, or whatever. I can maybe even farther, right? And there it is, right? So we're generating that using a formula. What if it didn't start at 0? Like, what if I, what does that mean? What if I wanted to add 7 each time, but I started from 3? So I did 3, and then I add 7 to it, so it's 10, and then I add 7, so it's 17, 24. All right, so each time I'm adding 7. Yeah, so I could add. Let's make this a little harder. So I'm going to say, what did I say? It's 3, 10, 17, 24. This is my arithmetic sequence. So with an explicit formula, I times 7 plus 3. So I can put my formula right in there. Does that work? Yeah. Right? 3, 10, 17. Okay. Let's say I wanted to generate the same sequence, though recursively. So we can take the idea that Jasmine had, we just want to add 7 each time, right? We start with a certain value, we're going to start with 3, we're going to add 7 each time. The same way we think about it in our own brains. We just need to keep track of whatever that number is. So I'm going to have another variable here, set my value to 3. What am I going to do in my loop? 2 things. I'm going to print my current value, and then I'm going to add 7 to that, right? So whatever my value is, I'm just going to print it, and then I'm going to say value plus equals 7, right? So it's actually kind of it's a little more like more words in terms of the generating this sequence, but it's pretty clear about what's going on. I should have skipped a line there. Okay, so you can see we can generate the same sequence, just we're generating it recursively now. Recursively meaning we're using the previous number in the sequence to generate that. Okay, so let me show you what the assignment looks like. Okay. All the assignments are going to have some reading, which I want you to at least skim through most of the reading and then dive into whatever's most interesting to you. Most important is, like this reading, there's actually a lot of kind of background reading, so just do what you want with this. As we get into more technical things, it's most important that you understand kind of the overall view of what the technical things are, and then understand how to look up when you need to understand exactly what the rule is. Because some of these things will get pretty, pretty detailed. Okay, so the code exercises. There are 5 code exercises for this assignment. First one is multiples of 3. So just generate the multiples of 3, right? And all of these should look very familiar based on the examples that we just talked about. FizzBuzz, so FizzBuzz program. So for each one of these, for example, the multiples of 3, you're going to have a class called multiples of 3, and it's going to be a file called multiplesof3.java, right? Okay, FizzBuzz, geometric sequence. So geometric sequence is like an arithmetic sequence, except that you're multiplying by something every time instead of adding. And so there are going to be multiple ways to do that. You could do that either with an explicit formula, or you could do that with recursively. Cubes. That's probably easiest with a formula. It's like whatever the thing is, you cube it and print it out. And then the last one is the Fibonacci sequence. Do you all know the Fibonacci sequence? It starts with 1 and 1. How does it go? You start with 1 and then 1, and then you add these 2 to get the next one. And you add these 2 to get the next one. Right? What's next? 5, 8, 15. All right. Okay, so the exercise is to print out the Fibonacci sequence like that. This one's a little harder because, but you want to do it recursively. Instead of saving one value, you're going to have to save 2 values. The idea is, if I have my 2 values as A and B, then to get this next value, I'm going to do A plus B. And then I'm going to just slide everything up. I'd recommend using 3 variables for this one. I think I put on here, oh yeah, it's easiest to think about having 3 variables. It can be done with 2 variables, so if you want a little challenge, then you can do that. I also put a challenge in here. If you print the ratios of the Fibonacci numbers, then that's kind of an interesting thing to see also. Okay, any questions? Yeah?
What does recursively mean?
Recursive means you're referring to the previous things in the sequence. So, for example, when we were doing this adding 7, whatever the current number is, you can add 7 to it to get the next number. Other questions? Yeah.
Is it on paper or can we do it online?
No. So this is all going to be okay. So this is all going to be in your GitHub. So you're going to make a new folder, a Unit 1 folder, and every one of these is going to be a separate file on that. You're going to make sure that it runs and it prints out the sequence.
But the quiz is going to be on.
Quiz will be on paper.
Oh, so we can check it out.
Oh, no, okay, so for the quiz, yeah, so the quiz is going to look like this. You don't have to. Okay, so the actual quiz. And I wrote in here, you don't need to be able to write the public static void main. I'm going to give that to you, and the class definition. So it's just going to be, for the quiz for this one, you're just going to be responsible for the code that's inside, just the declaring the variables and the loops. Other questions? Okay, good. Let's use the rest of the class to make sure that you're up and running. Like you can actually do this assignment. You can write the code, get it running, get it uploaded on GitHub, that kind of thing.